Hello. This set of videos will discuss the concept of writing methods. We will also gain a better understanding of the built-in C# methods that we have already been using in our code. The part 1 video will go over the concepts and we'll show some examples of previous methods that we're familiar with in order to help you better understand the concept of methods. The part 2 and part 3 videos will be solely dedicated to hands-on examples. Okay, a method is an encapsulated series of statements that perform a task. It's like a grouping of statements. Using the method is called invoking or calling the method. So the very first method that we created was way back on the very first day of class when we created a static void main method where we wrote hello world. So we also invoked a method on that day. So we both created a method, the static void main method, and we invoked a method that was written by someone else. When we use the WriteLine method, we are invoking that method. So thus far in this course, the only methods that we have created are the main method, and when we're working in GUIs and we double click on a button to put some code inside of that method, that's a method that we created, even though Visual Studio filled in all the keywords that we needed for that. We didn't have to really think about what was in the header of that method, but we're going to think about that a little more deeply today, and we're going to learn how to create even more types of methods. What is the reasoning for methods? Methods are easy to reuse. If you create something once, you can use it over and over again. You don't need to have repetitive statements. You can avoid what we call code bloat in the programming world. And also another reason is implementation hiding, which means we don't have to see the details of exactly how every single thing works. So for example, again, the WriteLine method, we don't know all of the statements of code that go into making that method work the way it does. All we know is that we can just use the keyword WriteLine and it works the way we want to, because whoever created that put it inside a nice little method where we don't have to examine the details of it. Okay, we're gonna do a lot of practice with writing methods. So every time a method is written, it must include both a declaration and a body enclosed in the curly braces. The method declaration includes 5 different parts. So it's a lot of stuff to process. We're going to go over each of the 5 individually. There is an access modifier, either public or private. And if you omit the words public and private, then C# just assumes that it's private. There are some other options like protected. You'll see a list of them in the textbook. At this point in time, you only need to understand public and private. We have the static keyword. So every method can be either static or non-static. Non-static is not a keyword. You either include the static keyword or you don't include it. Then you have a method return type. The return types are the data types that we learned about in chapter 2. So it could be a string, could be a double, could be an int, could be a character, could be a Boolean. But it is also possible to have a method that doesn't return anything at all. And we've seen some of these, and I'll show you some examples. If that is the case, then you include the keyword void. Then you give your method a name, and then you have the parentheses for optional method parameters. If you want to input some data into this method, you put those parameters in the parentheses. Then in the body, you can include whatever regular statements you like. And unless it is a method of return type void, you have to have a statement using the return keyword. And we'll see some examples of that as well. So this is a nice little piece to have handy for bookmark it to have as documentation when you're working on writing your own methods. Like I said, we're going to get into each of these concepts in more detail, but this is just kind of the summary page to remind you what those 5 pieces are in your method declaration. You have to write public or private. You can optionally write static. You have to put a return type. You have to give it a name, and you can optionally include your parameters. Okay, like I said, we've already been using methods that were written by someone else. We didn't have to write these methods. We just invoke them when we want to use them. We've also edited the body of methods that were created for us, like the main method and the button click method, but we've never had to actually write our own method with the declaration at the top. But we can, and we're going to in this chapter. Now, what I'm going to do from this point on through the rest of this video is I'm going to switch back and forth between the slides discussing the concepts and this other window where I'm going to show I'm going to apply the concepts that we're learning to some methods that we're already familiar with. So over here on the left is a list of methods that you should be familiar with. So we've got the write line method, the read line method, the stream writer write line method, and the stream writer read line method, string.format, the .toString, the substring, convert to int32, OK button click method, and then methods you create from scratch. So for each of these, we're going to understand those 5 pieces of the method header. Okay. For these methods, I mean, you don't have to know all this table that I'm filling out isn't something you have to memorize or anything like that. You don't have to know exactly how these work. I just thought it would be good to use the methods that you're already familiar with as examples for understanding these different aspects of a method. So we're gonna pretend that we were the people that wrote these famous methods, and we're gonna apply the concepts to see how we would write those, which of the keywords we would use in our method declaration. Okay, let me jump back. Okay, so the first piece is the accessibility. This limits how other methods can use your method. So like I said, the most common ones are public and private. And if you don't include an access modifier, it's private by default, but it is conventional to specify it anyway. I think it's a good idea to always include explicitly whether a method is public or private. Now, the methods that we are familiar with, when someone wrote them, they created them to be public, and that's how we are able to use them. But the methods that you create inside of your applications that you're using are usually private, because you usually only need to run those within that application that you are running. Right? We're not writing, some big type of method that we're expecting everyone who uses C# to use, right? The methods that we're using, we're just using in order to make our own application work better. So within an application, if your method is only going to be used within your own application, you set it to private. So, for example, let me jump back. So the write line method is public, and we know that because we didn't create it, but we can use it. All of these are public. The read line, the write line method for the stream writer, the read line method for the stream writer. So every method that we have invoked that was built into C# is a public method. But all of the methods that we create within our own applications that don't need to be used by other people or other applications, we've set to private. So when you create a click method, you might have noticed that it uses a private keyword. And any methods that you create in your own forms or elsewhere, pardon me, are going to be private. I apologize if this is small. There's a lot here, and if you're viewing the YouTube video on like a phone or not full screen, it might be difficult to see, but I am going to post this on the course website. So if you're following along, you can just pull up this document separately, or you can print it out, pause and print it out before you continue the video, if that would help you to see it better. Okay, so public or private is pretty straightforward. I will say that for the homework, exam, project, any method that you create on your own is going to be private. Okay, next is the static modifier. So you can declare a method to be static or non-static. Static methods are those that can be called without referring to a specific object. Instead, you just refer to the general class. So static methods are not associated with a specific object or variable. You can just call them at any time. Non-static methods can only be used in conjunction with an object. Non-static is not a keyword. You just don't put the keyword static in if the method that you were building is non-static. Methods within forms, within GUI forms, are always non-static because those are associated with the form object that we have created. If we were doing a more a complicated programming where we were writing programming code that isn't associated with a form, or if we were doing text-based applications, like some of the examples shown in the textbook, then we could use static methods. But methods within forms are associated with that form object, and so they are non-static. So applying this concept to the methods we're familiar with, the writeLine and readLine methods that we learned in the first couple of chapters are static methods. Okay, so when someone wrote those, they included the keyword static. Okay, if we were writing the writeLine method from scratch, it would be public static, and then we'll keep going. Same for the readLine method. Okay, it's not associated with any particular object. We can just call or invoke the writeLine or readLine methods freely. On the other hand, the writeLine method, when we're using a stream writer, if you recall from chapter 14, when we're writing data to a file and we use a stream writer object and we use the stream writer object name dot writeLine. So anytime you see the name of an object or variable that you've created dot the method name, that means that it's a non-static method. It's a method that can only be invoked in conjunction with a specific object. So the stream writer, writeLine, and readLine methods are non-static. So if we were somewhere, someplace, when someone wrote these methods, they wrote a method declaration as public, and then it does not include the static keyword because they're not static methods. Okay, methods like string.format. String is the name of a class. You can tell because it has a capital S. It's not the name of a variable or an object that I created. So it is a static method. Public static. How about the toString method? Well, I usually refer to it as the .toString method because it's always associated with a variable. So in some of our early coding projects or assignments, we would have like a numerical variable, and then we'd say .toString. So the .toString method is a method that is associated with a specific object or variable. And so it is a non-static method. Same with substring. We can only use the substring method in reference to a specific string variable. We have to name that string variable and then say dot substring. So that is also a non-static method. So hopefully as we discuss these concepts, then what we've done in the past when we've invoked these methods starts to make a little more sense. So the substring is public non-static. Convert.toInt32. Well, in this case, even though we have something inside of the parentheses, we have a parameter, a certain object or variable that we are converting. We're not actually invoking this method in reference to that object. So what I'm trying to say is convert is the name of a class. Okay, we didn't have to put the name of our object dot to int32. So there's two kind of different approaches here to methods. One of them is to have it be a non-static method so that you have to name the variable and then the method is built in with that variable. This is a different approach where this is just a static class that can be called without a reference to a particular object, even though we put a variable as a parameter. So this is a static method. Public static. Okay, when we double click on a button and it generates a click method, that click method is associated both with the button and with the form as objects. And so that is a non-static method. Now, when we are creating our own methods, if we're creating a method within a GUI form, that's going to be non-static. And methods you create anywhere else could be static or non-static. So since in this class we're doing everything within GUI forms, when you're creating methods for the homework exam project, they're pretty much all going to be non-static methods. But if you were doing a text-based, or if you do other programming in the future, it is very common to create static methods as well. Okay, next is the return type. Every method has a return type, and that indicates what kind of value the method will return to any other method that calls it. A method can return at most one value, and if a method doesn't return a value, then its return type is void. So back at the beginning of the semester, I told you to type static void main. Now we know what that means. Main is a static method, and it has no return value. If the return type is not void, then there must be a return statement in the method's body that returns a valuable, or a value or variable of the type specified in the method header. So in this case, we're seeing an example of a method that has a return type of double. And so somewhere in the method body, you have to have a statement using the keyword return, and that returns something that is of type double. So let me go to my examples. Okay, so the writeLine method, the very first method that we learned to invoke in our code, when we wrote writeLine and then in the parentheses we wrote hi, there was no value returned to us from that method. This is a method of return type void, because as a result of running that method, we didn't have to save any type of value or variable as an object or as a variable in our code. On the other hand, when we use the readLine method, the result of that is always a string, right? So somewhere, let me just pull up Notepad. I want to make sure everyone understands this concept. So back in our beginning code, if we wrote right line, hello world, this code, this statement can stand on its own. It's not returning any value to us. It's just doing something. The computer is printing something, but it's not calculating or resulting in some value. On the other hand, when we use the readline method, this didn't just stand alone. If this stood alone, then it doesn't do us any good. Anytime we use the readline method, we ended up saving it to a string variable, right? So when we invoked this method, it returned some value. In this case, it returned a string. And so then we saved that string to a string variable. So this method, we invoke, this is an example, these are examples of invoking the methods. Whoever wrote this method wrote it to have a return type of string. So this is public static void. This is public static string. The streamwriter's writeline method, same thing. It does something very important. Just because a method is void doesn't mean that it doesn't do anything. It just means that it doesn't return some value to us that we're saving in a variable. The readline method, when we're reading some value from a text, it returns a string value to us. That is its return type. That's why anytime that we use the readline method, if we're trying to read in a number, we have to convert it because its return type, what it's returning is a string. So this is a public string method. The streamwriter's writeline method is a public void method. Okay, the string.format method, we haven't used this a ton. I talked about it back in chapter 2 or 3. It takes one string and converts it to another, so it returns a new string. It's a public static string method. Okay, when we have a number and we convert it to a string with the toString, you can guess, the name of the method says right in it that it has a return type of string. This is a public string method. Same with the substring method. It returns a string to the user that you have to save. How about convert.toInt32? Well, the name kind of gives that one away too. We input some text and we get out. It's almost like a factory machine. What you put inside of the parentheses is what you put into this machine, this method machine, and what you get out of it is your return type. So your input is your parameter in your parentheses. Your output is your return type. So here, the return type for convert.toInt32 is integer. So when someone wrote this method, they wrote public static int. The event methods, like a clicking method, when the user clicks on the button that you created, a bunch of stuff happens, but no specific value is given to a variable, is returned from this method to be saved as a variable. So the click event methods are void methods. And when you are creating your own method, you can create a method of any type, including void. And in the next video, I'll show some examples of various return types. Okay, the next is a method identifier. It must be a legal C# identifier following the rules we learned in chapter 1. It's generally a verb name because methods do something, just like verbs do something. It's conventionally capitalized, but it doesn't have to be. In the example, the quick example I wrote to put on the slide, I didn't capitalize it, which is legal, this code will run, but the convention is to capitalize your methods. We've seen in all of the methods created by other people that we've invoked, those all have capital letters. So the identifier for each of these is just the name of it. So write line, read line, and so on. All right, the last piece of your method declaration or method header is the parameters. So parameters are variables, 0 or more variables, that hold data that you pass into a method when you invoke that method. Your parameters must be separated by commas, and the contents within your parentheses are known as the parameter list. So this example on the slide is not a very good example because we have some input parameters, a parameter list here, an integer and a string, but then within our method body, it doesn't show how those are used. Granted, this is just pseudocode, and probably somewhere we would fill out how those variables are used in this method body. But pretty much always, if you have some input parameters, you're going to use those variables for something inside of your code. And you'll see, again, in the part 2 and part 3 videos, some examples of how you would use the parameters within your method body. But for now, let's jump back and finish filling out that Word document, applying this to the methods we're familiar with. So in this case, for a WriteLine method, anytime we called WriteLine, we had to have some text inside of the parentheses, right? I told you that that was just how the method worked and to just remember that rule of thumb. Well, the reason that it is that way was because whoever wrote this method specified that the parameters of this method would be a string variable. So it could be like string x or string str or something like that. I'll just say, I'll just use x for all of my variable names just to keep things simple. So when they wrote this method header, it probably looked something like this: public static void WriteLine string x. Okay. Again, you don't need to know this, but I'm just applying the concepts because we already know how the WriteLine method works and why it works the way it works for our code. And so hopefully seeing the specific characteristics of this method helps you to better master these 5 things that we need to learn about methods, so that when you're writing your own, you can remember what you learned from these examples. Okay, the readline method. If you remember, I just told you, remember by rule of thumb, when you use the readline method, you just have opening, closing parentheses with no parameters. So here, the parameter list is none. Okay, this WriteLine method also had a string, maybe string x we'll call it. Readline, again, has no parameters. Okay, the format method. In this example that I'm showing you, you can see that when we invoked this method, when we wrote it in our own code, not that we wrote the method, but when we wrote the code to invoke this method, we put 2 parameters in. One was a string, our literal string, and the second is the string to replace our placeholder. So in this case, this method has accepted 2 parameters, maybe string x and string y. So a version of this method somewhere was written to accept at least 2 strings. Okay. This isn't exactly how it was written, but just to demonstrate the concept. Okay, Now, a lot of methods, and I'll get to this concept, and when I do an example in the third video. Um, there's a concept that we call overloading methods, which means that you can write a method to have different definitions and to work in different ways depending on different parameter lists. So there's one version of this format method that accepts one string. There's a version of this format method that accepts two strings. There's a version of this format method that accepts three strings, and so on and so forth. So there's a lot of different versions of this format method. This version that I gave in this example accepts two parameters. So I've just demonstrated if you were to write a method similar to this, then you would include two parameters in your parameter list when you are writing your method header. Okay, same here. There's a version of the toString method that accepts zero parameters, right? We can just do toString opening closing parentheses with nothing in there. In this case, we've used a version of the toString method that accepts one string. Let's call it something different so you remember that it doesn't always have to be called X. All right, the substring method, I instructed you always includes two numbers. The first number represents the character position, and the second number represents how many characters we're taking from the original string. So here we had two integer variables, an integer, okay, maybe called position, an integer, I'll just call it num. It doesn't really matter what they're called. And so then when the person who wrote the method, they used those integers in very specific ways, right? One of them is specifically the position, one of them is how many characters, and those have to be written in the same order. When you're writing a method, whatever order you put your parameter list in, the person who invokes your method has to input those in the same order. Right, so when we call the substring method, we always put the position number first and the number of characters second. Okay, converting text to an integer takes one parameter, which is a string. The click event methods take some special parameters on object, event args. You don't need to know what these are, as this is code that is automatically generated for you. So as a beginner, you don't need to understand these, but those are the parameters. When you double click on a button and its method is generated and you look at that method in your code, you'll see that it looks like this. That's too much text to write in one line, but something like that. Okay. When you're writing your own methods, you can include any number of parameters or none. Just depends on what you're trying to do, the specific problem you're trying to solve. Okay, so those are the 5 different characteristics of a method that you have to specify when you're writing a method. And I hope that these examples of methods that we're already familiar with has helped you to understand when something is public versus private, static versus non-static, what its return type, its name, and its parameters. So I wanted to give examples from both sides of understanding methods that already exist, and then in the next video, I'll talk about all of these same things for methods that we're creating ourselves. Okay, here's a slide that gives you a little more detail on parameters. Formal parameters are the methods that you type when you're actually writing the method, and then actual parameters are the arguments that the person invoking the method types in. So when we use the write line method and we type hello world inside of the parentheses, hello world is our actual parameter. Okay? We don't see the formal parameter, which is the way that they wrote that string variable when they wrote that method. Right? We don't see all those details because we didn't write the method. We just know our actual parameter, which is the argument that we use, or argument is another word for parameter, when we're invoking the method. I mentioned some of this as I was going over the examples, but methods can take any number of parameters and of any varying number of data types. They just have to match in their relative position when you invoke the method. Okay, a class or like a file or a form that we've created in this class can have any number of methods in it. Methods can't be created inside of other methods. You can declare new variables and constants inside of your method body, but they are considered local to that method, meaning that you cannot refer to those variables outside of that method. They go out of scope when the method is exited. Okay, so here are some hints and tips when you're thinking about how you want to design the methods for your code. If the code that you want to put inside a method calculates a number, then likely your return type will be a number, like an int or a double. If you are creating a string, then the return type will be string. So the hint here is if your method creates something that you then want to let the user save to a variable, then whatever type of something that is, it will be your return type. On the other hand, if you have code that you want to be executed to complete some action, but it doesn't result in something new being calculated or created for the user to save, then the return type will be void. Okay, and if you're wondering whether or not your method should have parameter arguments or a parameter list inside of those parentheses, think about it this way. If you want your method to do exactly the same thing without variation every time you call it, like when we invoke the readline method, that does the exact same thing every time we call it, then there are no inputs, no parameter arguments. If your method does something different each time, depending on some user input, or depending on some like different level of pricing or whatever it might be, if the method sometimes calculates one way or using some inputs and a different time you want the method to behave a little bit differently, then you'll need to accept parameters in a parameter list. A lot of the time when we are creating our own methods, well, I won't say that one happens more often than another. I would strike out that sentence on this slide. I would say they're equally common to have methods with parameters and methods without parameters. Okay, come back and join me on the next video, and I will take all these messy abstract concepts and we will put them into real practice and really start getting this concept solidified in your brain.